Okay, this is the response to a question I was recently asked. So multiplying binomials, many of them. In this case, we have a ton of them. So how would we put all of this together? I would look at this as separate problems. First off, let's look. We have 1, 2, 3, 4, 5, excuse me, 5 factors. I'm just going to start off the easiest way I know, and I'm just going to get rid of this x here by distributing it into the first expression. And I think we can agree that that gives us a new expression when we combine these two, and that is x squared plus 10x. Right? Then what I'm going to do is I'm going to look at this as a series of problems, and if you don't mind, I'm going to just put this multiplication sign right here. There's a bunch of them, but I just want to show you this one because I'm going to separate this into this times this, and then I'm going to multiply these two. Let's take a look at what that might look like. So x plus 2. I'm holding on to this. So I'm going to hold on to that. Right now I'm going to do this. I'm going to use FOIL here. First, outer, inner, last. So first, outer, inner, last is what that's going to look like. So we have x squared times x is x cubed. X squared times 2 is 2x squared. 10x times x is 10x squared. And 10x times 2 is 20x. From here, I'm just going to clean this up. Combine like terms. Remember, we have the whole second half of this problem left up here, this piece up here. So I'm just going to remind you one more time, because this is what happens. People forget that I'm holding on to this piece right here. I'm going to do this piece separately. So right now, I'm doing this piece right here, right? So what does this thing look like? Oh, let me just be clear about this. Make sure that when you're combining like terms, you keep in mind that you've got to only add like variables. That is to say same variable, same exponential value. So there are no other x to the third, so I'm going to keep my x to the third here. But there's 2x squareds here, and there's 10x squareds here for a total of 12x squareds, right? And I'm sorry I'm pluralizing that, but I just want to make sure I'm being clear about how I got that. So I'm gonna, now this is the piece I'm going to hold on to. So now I'm going to hold on to this piece. So I'm going to hold this piece, and I'm going to take this piece up here, and I'm going to drag this thing down here. I'm going to work on this problem now. Whoops. Sorry. So I'm going to work on that piece now. This thing is a very, very arduous process, but this is how you do it. X minus 4 times our x minus 6 here, right? I'm going to go ahead and FOIL this out. So remember, it's first, outer, inner, last. So I'm going to this times this, then this times this. Then I'm going to move on, I'm going to move on to this times this, and then this times this. So let's do the first part first. X times x is x squared. X times negative 6 is negative 6x. Negative 4 times x is negative 4x, isn't it? And negative 4 times negative 6 is positive 24, isn't it? Combine like terms. There's an R in there somewhere. Terms. Combine like terms. Remember what we said when we said combine like terms, that combining like terms means we only add variables to matching variables. So there are no other x squareds here. So here's my x squared. I have negative 6x's here, negative 4 more x's here for negative 10x. Isn't that right? Plus 24. Whoops, sorry about that. Plus 24. Now, finally, we had this piece that we said that we were going to hold on to. So we're going to so let me be clear about this. Let me be clear about this if I can. This piece right here is a combination of me multiplying this times this, right? This piece right here is us multiplying these pieces here, right? Remember, I put this multiplication sign in the middle, and I said we're going to come back to that. Well, now I'm going to actually use that. And I'm going to multiply this piece times this one. So that multiplication sign that we put at the very top earlier is this one right here. And now I'm going to multiply that by this piece. So x cubed plus 12x squared plus 20x. This part is going to be a pain. You can definitely do this, but it's a little bit of a pain because if you look at what we have here, If you look at what we have here, we have a trinomial times a trinomial, which means we're going to multiply 6 times, 6 different multiplication problems. So let me just outline what we're going to do there. We're going to multiply this times this, then this first piece times this second piece, then this first piece by the third piece, and we're going to do that, right, over and over and over again. Then we're going to do this times this, then this times this, and then this times this. And when we thought that wasn't enough, we're still going to have this last piece here, and it'll be this times this times that, and this times the other. And then we'll clean all this crap up. So this is a lot of very, very tedious and monotonous work, but let's do it anyway. X squared times x cubed. Remember that the rule is x to the m times x to the n is x to the m plus n. That is, we add the exponential value, so we get x to the 5th power. Then we get 12x to the 4th power. That's me multiplying by that piece. Then we get 20x squared. 5th, 4th, oh, 3rd, isn't it? Because this piece times this, 1 times 20 is 20. X squared times x is x cubed. Sorry about that. All right, now we'll follow the white lines. I'm going to do this piece right here. So negative 10 times x cubed is negative 10x cubed. Negative 120x. Oh, this is to the 4th. Somebody already caught that. Good job, whoever you are out there. And then we get negative 200x squared, right? This is really a lot of math here. All right, let's do this one last piece, and then we'll start to put it together. Now we're going to follow this 24 right here, right? So we're finally at our last piece. I just want to make sure that we're still clear on where we're going. We're on this piece, right? Everything in yellow is us following this piece to here. Everything in white is us following this piece to over here. And lastly, we're going to follow this piece right here. We'll do that maybe, I don't know, in orange or something, just so you can follow what we're doing. So we're here, right? We're going to follow that piece right there, all in orange. And 24 times x cubed is positive 24x cubed. 24 times 12x squared is, now I have to put you on hold for a second. So 24 times this is positive 288x squared. And lastly, we have this little piece over here. Let me drop this so you can see if we can see this whole thing at one time. Lastly, we have 24 times 20x, which is 480x, 480x. Man, that's a lot of work. So let's start gathering our like pieces and see if we can get this whole thing put together. We get x to the 5th. I'm just going to combine my like terms. X to the 5th, there was only one of those. X to the 4th, we have 12 of them here, negative 10 of them here. That's 2x to the 4th. That's all our x's to the 4th. So we have 2x to the 4th. We're adding them, right? X to the 3rd, we have 20 of them here. We have negative 120 of them here. It gives us negative 100. Negative 76, that's what I got. Negative 76x cubed. And now we're on our x squareds, aren't we? And we have negative 200 of them here. Positive 288 for a total of 88, right? Of 88x squareds. Wow, that's a lot of stuff. Plus 480 x's. And you can check my math, but that's my solution. That was a lot of work. So just to recap, how did we do all this stuff? We broke this down into different problems. We did this problem first, right? We distributed this into this to get that. Then we multiplied this times this, which gave us this whole piece right here, right? That gives us this whole piece done right here. We put this multiplication sign in right here to remind ourselves that we weren't done, but we broke this out as a second problem. We did this times this, and that's this piece right here. We FOILed that out. We combined our like terms. We simplified everything. And then we gathered up our two huge pieces, and we used the distributive property of multiplication over addition, and we multiplied all this out and got our final solution of this. So hope this worked out right. Thanks for watching. If you haven't already subscribed, please subscribe. Thanks.